Morning, everybody. I'm going to talk to you first a little bit about our 6G Flagship Program, what we are doing, what is the scope of the program, etc. Then I'm trying to enlighten you a little bit on how we as 6G research community see future developing in mobile world. So, like Ari mentioned, Flagship started 2018. There was a national competition, and which we happened to win at the time. So we had an early start for 6G. We were really the first one around the world, and it was not easy to be the first one. But later on, it was nice to be the first one. So we are still reference to other similar programs globally, defining the 6G research agenda and the directions how the 6G research should be taken forward. We are the largest ever research program operated at University of Oulu, definitely one of the largest research program in our country in public research. Out of our budget, 10% unfortunately comes roughly only from Academy of Finland. More than half comes from different externally funded projects. University of Oulu contributes directly the same amount of Academy of Finland plus our faculty contribution on annual budgets. We are relatively big. We have 200 researchers on wireless alone, another 200 in other disciplines which are important: material sciences, electronics, computer science, future applications, and so forth. We are active in publishing our results, of course. We are quite proud about our publication numbers and doctoral theses made. They are highly referred. We have highly cited researchers in our group. We have academic professors now, one academician as well. Lots of doctoral theses done. Lots of companies collaborating with us, both in Finland, but mainly outside Finland through numerous European projects and also bilateral projects overseas. So our research agenda is quite broad, and I still see it as quite unique in this scale. So of course we all know that sustainability type of thinking is now the trend that everybody has to follow it, but we are really doing some real things to support those development goals. We are also trying to change a little bit the future regulation related to telecommunications field to support sustainability thinking. We are also trying to change the future businesses related to mobile communications supporting sustainability development goals, and most of everything, our technology-related selected research areas are looking very difficult issues related to energy efficiency, recycling of materials, etc., etc., etc. So it's really broad scope of research. We are covering huge number of different disciplines, but so far so good, and we are still continuing along the same tracks. The second phase of Flagship started this last spring, and then we redefined, or let's say wrote a little bit our strategic research agenda. From the very beginning, we have had 4 strategic research areas which are important for 6G wireless communication systems development, wireless connectivity solutions, which covers mainly the activities at Center for Wireless Communications 2 research units, device and circuit technologies related to how we implement actually those future gadgets. That includes lots of electronics, etc. Then distribute intelligent wireless computing. All these fancy machine learning, artificial intelligence tools that we can think of putting to future applications that we need to optimize the future networks and services. Then the last but not least, services and applications. We have really extensive 5G test network facility that we are now driving towards 6G capable test and validation platform where we want to, and we are testing future services of various sorts. The areas where we are active in testing our applications and services related research topics are selected to be within health, industry, vehicular, and energy sectors. So there's already, and this has been more or less from the beginning of our Flagship 2018. So there's a very strong linkage already to this 6G ESS program from Flagship from these grounds alone, energy and health. Those are our application areas. So, for example, as one resemblance of our 5G test network activities is that there's one small cluster of our test network at University of Oulu, a hospital area where different medical gadgets could be tested through our 5G test network. Of course, global collaboration is a must, and we have strategic alliances with different regions and countries with whom we have active collaboration ongoing in different ways. And global collaboration is actually very important in our field because we aim at defining as a community, research and development community, global standards. Without global standards, we would not have global mobile phone markets, for example. Standards are very important. Our role as research organization remains vital until the standardization is up and running. Until then, research community is suggesting different alternatives, what should be the contents of standard. The standardization itself is highly political. Companies of different sorts are basically defining what do they select to the bucket in the end of the day. So, about mobile communication systems and generations of them. We all know that in 90s was probably the time when we all started to have our own personal mobile phone device. It was meant for making phone calls, maybe some text messages. With 4G technology, about 10 years ago, we started to have mobile internet in our pockets. Smartphone technology came in. Now, when we are talking about 5G and 6G technologies, maybe you are not so much aware of what is coming around the corner. The target is to have connectivity of various sorts of things, processes, automating the society of different sectors. Industrialization 4.0 is one of the key things pushing this forward, improving the productivity of industrial production. Wireless connectivity is a must in modern factories. Also, there's a lot of discussion of personalized health. We need all kinds of different sensors measuring our vitals. And then there's a huge system potentially behind it, making analysis of our personal health situation, maybe triggering some warnings and so forth. But no one really knows what is the next so-called killer application for the future. And this is what is puzzling currently, still even today, research world. There are some clear needs for having 6G. 5G technology came just a couple of years ago that you could buy these handsets. They do not differ at all from what you have had already for 10 years, the smartphone technology. It's mainly completely hidden from plain consumers what 5G is capable of doing. There are lots of novel innovations that enable 5G to be used for automated control of different machines with very, very short delay. So this almost real-time control loop is about to come out. So this verticals productivity has been driving development of new technological solutions for industrialization 4.0. Of course, we know that there are many other things that are concerning the world today. We have lots of troubles around the world. We have climate change, we have urbanization, we have some crises here and there. So we have a huge number of societal challenges. The question is how much technology can help and should be used to try to make solving those huge problems a little bit easier. And we do believe that wireless connectivity has lots of things to offer in providing solution. Maybe the most concrete that you might be quite a bit familiar with is the UN SDGs, 17 of those. And we have actually thought about these things. And in our opinion, wireless connectivity can play a role in every 17 of those. Somewhere it's bigger, somewhere it's smaller, but it is everywhere. If you think about different sectors of technology, probably the same situation. So technology, in our opinion, is a key to solve lots of global challenges. That is really driving our work quite a bit. Then there are also other technology enablers making these future societal needs for automated society possible, like development of artificial intelligence, robotics, for example, automated driving, and so forth. So wireless alone is not enough, but it needs to be integrated to other things. So massive automation of society is really what is pushing us forward. And quite often it's said that 6G will merge physical, digital, and biological worlds in different ways to have future really unbelievable applications that no one can imagine today. We have lots of challenges compared to 5G. We have to try to do it better, more efficiently, push everything to the limits far more than 5G was able to do, and so forth. The standard is planned to be ready 28. You should be able to buy these gadgets from supermarkets 2030, if everything goes well. When we were developing ourselves or preparing ourselves for this national flagship competition, we actually had a chance to make a very nice video with some professionals showing future vision, what 6G could bring in. So maybe we can now have a look at this vision video shortly. So many of these application areas shown in this vision video are actually ongoing or partially tested already. We need to develop existing technology capabilities further in order to make this happen, but all of this is quite realizable. So there has been in past also visions for the future, and if I look a little bit back what was envisioned in research community, for example, about 20 years ago, it was this always best connected vision, but what we had in the end was basically smartphone technology. When we were developing 5G, we were talking about, which started about 10 years ago, to connect the tens of billions of devices to the internet, so Internet of Things. Well, quite simple things are at consumer markets today. For example, these wirelessly controlled lighting systems that you can buy even from Lidl today is one example. Today, when we are thinking about what is 6G application for consumer perspectives, we talk about metaverse, really fuzzy word, no one really knows exactly what it would mean, and digital twins. These are the two things probably changing quite a bit how we utilize mobile network technologies for future applications. Digital twinning means that we have exact model of rather complicated process, typically industrial process or vehicle of different sorts. We model it digitally. We collect real data from real physical world and use powerful AI algorithms to use the characteristics of real-world phenomena in this digital model of this complicated process. And then we can play with this digital twin in cyber world without actually implementing it. And that is going to change quite many things in the future. Metaverse, no one knows what it exactly will mean, but it means a really immersive experience through new types of end-user gadgets like these Googles of different sorts, or anyways, new ways of projecting the image, 3D image, to consumers. What we see and believe strongly in is that new application areas will be driving the development of mobile technologies for the future. We have to look each and every major application area, what we call verticals, individually. What are the needs? What are the types of services? Who are the users? What is the business behind it? And they are all so different. When we then write down the technical requirements related to these different application areas, they vary hugely. So in the future, we will see lots of differentiation in technology solution, but also the types of products and applications that will be used in different segments. In order to make those efficient, in order to have sustainable type of systems development and services related. Looking 10 years back, looking at what European Commission was defining as the major technology challenges for 5G, lots of different things on the left side. These are all still valid for 6G development. Maybe the numerology has been changed to be a little bit more ambitious, but these all are still there, exactly like they have been written there. Maybe there are some new ones as well. What does this tell us? Has nothing happened in 10 years? No, this is not true. But unfortunately, the fact is that making major technology leaps takes much more time than we wish to think. So typically 20 years is required to make the major technology changes, in our field at least. 2015, global regulation, ITU, Standardization Regulation Organization, defined the requirements for 5G in this so-called IMT 2020. Within the next 2-3 years, similar technical requirements will be set for 6G. And once those have been laid down, we know exactly where the targets for 6G are. We as a research community are trying to influence on definition of these requirements and to have right types of things being required from the future systems. The list of these technical parameters is not enough alone. What has been discussed recent years is that we also need some value-based requirements besides these hard technical parameters. Some of the things that we have been discussing in the research community since 2018 are shown here, that really greatly improved transmission and data rate capabilities, security, reliability related issues. One new thing is coming along, that very accurate positioning technology should be incorporated to 6G. One of our colleagues who worked with us a couple of years, he started up a company and they have demonstrated already sub-millimeter level positioning capability using wireless technology. So we are really moving fast to have accurate positioning in wireless systems. GPS-based positioning, which is mainly operable outdoors, giving us some meters of accuracy, maybe in practice tens of meters of accuracy, is clearly not enough. So we are going to do that. Also, utilizing all senses of human beings in a communication process is coming out. Already now there's lots of new sensors developed for scent and so on. Of course, our eyes are very important, and what the capabilities of eyes are being investigated in these AR, XR, VR community quite a bit. The future services will not be unique. They will be depending on the time and place. What are we doing? It will be different in university context, hospital context, downtown shopping area context, and so on and so on. That is most likely the biggest difference that we as consumers will be see from services side in the future. If you are interested in digging in a little bit deeper about our visions, not only our own visions, but we did carry out an exercise with some of the global lead researchers writing a series of white papers on selected areas. There you can find lots of details how different perspectives are foreseen to be developed in the coming years. So if you also want to find out a little bit more what we are doing, 6G Waves magazine is good source of casual reading, and visit our website to find out more. Thank you.
Questions. Now is the time to use the event. I have one question for you. This is more technical rather than philosophical. As you mentioned, and it was evident from your presentation, there are a lot of contradicting requirements when we are building 6G, like low latency and high data rate. Do we foresee, let's say, many versions of standard, or will there be only one?
That is a tough one. And what is 6G? Many people understand 6G as to be one standard defining mobile communication system called 6G. We as researchers, we more, when we're talking about 6G, we mean the technology family overall required in 2030 era. But 6G standard as itself has to be flexible enough to allow and tolerate the most important and critical application scenarios. So there will be flexibility. There's already now flexibility. There are 3 different scenarios defined for 5G. Now there's speculation for 6G that maybe 6 would be a nice number to have these different scenarios. We don't know yet. But it will be optimized for different use cases. Another thing which is being developed currently is the so-called open radio access network technology, meaning that currently the base stations are black boxes offered, for example, by Nokia and delivered to customers. In the future, there's a strong push from certain countries to open it up, to have it more modular structured, have more generic hardware platform, and then define different capabilities of this network through software implementation. And if this open radio access network technology comes into the play, then it's much more easier to tailor-make it for various different application scenarios. So the future looks like it's going to support it. It might take quite a bit of time, but that's what's happening.
Okay, thank you for your excellent talk and also a brilliant video. We have now 2 questions in the event room. So the first one is that how many connected devices we have today? What has been the growing rate recently?
I haven't looked at the numbers, but I think it's something like, on average, I mean, as many as we have people on the planet. Not everybody has it, but some people have several. And we all know that from our households that we have other things than besides our mobile phones. We have wireless connections to different gadgets like TVs and so forth. We have Bluetooth headsets and so forth. Maybe I have at home maybe 20 wirelessly connected gadgets. So it's quite a big number. It's quite a big number. And the growth will come through different small things, like quite typically sensing our environment, like air quality. For example, at University campus, we have about 2,000 sensors distributed across the Linnanmaa campus, sensing different parameters like temperature, humidity, CO2 level, etc. And there are many. So that type of sensory devices will really explode the number of gadgets more than anything else.
Okay, thank you. And another question was how to enable inclusion and diversity in 6G?
Very important question. And as one of the research themes we have selected from the very beginning is to look at specifically remote areas connectivity solutions. Remote areas exist in Western developed world, but more so in developing emerging economy countries. And the challenges in these two, for example, these 2 segments are very different. For us, it's really, if these digital services doing our daily things every day is required really, we have to be able to do it also in Lapland in the middle of nowhere. In developing countries, they have no connectivity, they have no services, they have absolutely nothing. So that would seriously increase the productivity and quality of their lives. So that is one thing we are doing it quite a bit. It's not easy. There are technological challenges, maybe more political challenges, regulative challenges, and many things to be taken into consideration. And one big thing is what we want to ask: what is the role of communities and governments in the future in putting down the future services and related networks? Now we are relying on commercial operators only. Do we need something else?
Thank you. Maybe I will just end up with a final question. So you show the excellent video and all the possibilities for the future, but what do you think in priority? What is currently the biggest challenge concerning resources? Is it research funding or need for more researchers to own or international networks in Europe and worldwide? What is the priority list?
So I think the challenge is throughout the Europe very similar. And this RRF funding, Rapid Recovery Funds instrument after COVID or during COVID, actually released a lot of funding for high technologies, research and development everywhere in Europe. Not so much in Finland yet, at least. But when discussing our colleagues even in Mediterranean countries where they typically have had serious challenges in funding their research in this area. No, they have plenty of money, but they don't have researchers. Industry is growing, industry is recruiting, it's happening everywhere. It's especially in Oulu area, it's very evident. We have lots of researchers going to join industry. That's of course our role, but at the same time when we have good times in getting research funds, it's actually not so great. So that is the biggest bottleneck. Where do we find great researchers? And we are really speeding up our recruitings and all the time looking for talents. So if there are any interested people to start to look at 6G challenges with us, please just contact us and we can do lots of fun things in the future.